Okay, so the next special cases we want to consider are parallel lines and perpendicular lines. We'll begin with parallel. So two lines are parallel to one another if they lie in the same plane and they never intersect. I have two vertical lines. There's a vertical-ish line and another vertical-ish line. These two are certainly parallel to one another. They're not going to intersect. But do you suppose the same is true of horizontal lines? Well, sure. Here are two relatively horizontal line segments. Those will never intersect either. What do we know about such things? Well, we know two lines are parallel if they have the same slope. So we can inspect their slopes if we want to discover whether or not they are parallel. See, I have an image here, red dashed line and the blue solid line. These two are parallel. They have the same slope. Okay, let's try it out. Let's see if we can decide if these two lines are parallel to one another. I have the line y plus 9 equals 3x, and the line 3x minus y equals negative 2. Well, to know if they're parallel, I should discover what their slope is. In that case, perhaps it would be best if I put it in slope-intercept form, which is to say, let me solve for y. First one here, simple enough. I can just move the 9 over, subtracting 9 from both sides. The line then becomes y is equal to 3x minus 9. The slope of this line, that's always the coefficient on the x term. Coefficient there is 3. I'll do the same thing to the second line here. More than one way you could go about doing this, but I'll just subtract 3x from both sides. That leaves me with negative y is equal to negative 3x minus 2. I want y, not negative y. I can think about that as a negative 1 times y. Then it's clear I have a sort of multiplication here. To undo multiplication, I can divide. I'll divide everything by negative 1. Divide each term by negative 1. Negative 1 and negative 1. Dividing by negative 1 has the effect of flipping the sign. Right? Division by 1 doesn't change anything, but that negative is going to change the sign. So negative divided negative becomes a positive. Positive 3x. Same here, negative divided negative becomes a positive. That becomes a positive 2. By inspection again, slope here is 3. So since we have the same slope, they are parallel. Okay, once more. And feel free to decide for yourself and then zip to the end and see if you're right. We'll look at this one. Now this one's already in slope-intercept form. Whenever we have it in a function form, that's going to be in slope-intercept form. So I can just look here. Coefficient on the x. I must have been in a 3 kind of mood when I wrote these examples because the slope here is 3. Inspecting the second one, pretty close. I've got it in 2y equals 8x minus 2. I want that in y equals form, so I will divide every term by 2 to clear that out of there. That'll give me y equals 8 divided by 2 is a 4, so 4x, and then 2 divided by 2 is 1. That negative out in front makes it a minus 1. Inspecting this thing, slope is 4 here. So their slopes are not the same. Different slopes here, so they are not parallel. final special case that we want to consider are perpendicular lines. We say two lines are perpendicular to one another if they intersect at a 90-degree angle. Now that's going to happen clearly if one is vertical and the other horizontal. You get that nice 90-degree angle right there. Now, if we don't have a vertical and a horizontal situation, we can still say something interesting. We can say there's slopes. Slopes of two perpendicular lines are negative reciprocals of one another. Pretty fancy terminology. What do we mean when we say negative reciprocals? Well, negative, that just tells me to flip the sign. So if the slope of one line is positive, the slope of the line perpendicular to it must be negative. Also, reciprocal. Reciprocal means flip the fraction. Flip the fraction. So if I have the slope of one line is m, the slope of a line perpendicular to it must be negative 1 over m. So if I had, say, the slope of one line is 17, negative reciprocal of that, say, negative 1 over 17. The slope of a line is negative 2 over 3. The negative reciprocal of that says flip the sign, it becomes positive, and then flip the fraction, that becomes 3 over 2. So flip the sign, flip the fraction, negatize, and flip. Negative reciprocal. All right, let's give it a try. Let's see if these two lines are perpendicular. So I'll start here. I'm going to rewrite this so that's in slope-intercept form. I will start by just subtracting the x so that I have negative 2y is equal to negative x plus 3. There's nothing written out in front of the 3, so it's taken to be positive. So that's a plus 3. Divide by a negative 2 everywhere. Clears that out so that I have y equals negative, negative. That becomes a positive. I can write that as x over 2. Negative positive changes that to a negative. That's a minus 3 over 2. Now, I tend to think of division as multiplication by a fraction. In that case, this is 1/2 times x. Then it's plain to me to see, there's my slope right there. It is 1/2. We'll do the same thing to the second line. Subtract 4x from both sides so that I have 2y is equal to minus 4x and plus 1. Divide every term by 2. Y is equal to, that is 4 divided by 2 is 2, but it's negative. So negative 2x plus 1/2. The slope here is negative 2. Then I ask, are these negative reciprocals of one another? I have positive 1/2 and negative 2. And if it helps you to see the fraction, feel free to write that over 1. They're opposite signs to one another. This is positive, this is negative. So check on negative. This is 1 over 2, this is 2 over 1. That's a check on reciprocal. They are perpendicular. All right, let's try it again. Grab the slope of this thing. It's already written in slope-intercept form. We've seen that before. It's the coefficient on x, so it's 3. We'll rewrite this one. I'll subtract 6x from both sides. That gives me 2y is equal, that's negative 6x plus 5. I will divide every term by 2. This gives me y. Let's see, negative 6 divided by positive 2 is a negative 3. And that's just 5 halves. 5 over 2. So slope here is the coefficient on the x. That's negative 3. So these are negatives of one another, positive 3 and negative 3. So there's a check on negative, but they are not reciprocals. They're both 3 over 1. So since they are negatives but not reciprocals, they are not perpendicular.